Now our next reaction is ozonolysis. Ozonolysis refers to organic chemical reaction where ozone is used to cleave the unsaturated bond of alkenes, alkynes and compounds which have such kind of functional groups. So it is an organic redox reaction. What are the major highlights of this reaction? Oxidation of alkene with the help of ozone. This can give alcohol, aldehyde, ketone or carboxylic acid. Alkynes also undergo ozonolysis to give acid anhydride or diketones. Ozonolysis of elastomers also take place and this is known as ozone cracking. And azo compounds, ozonolysis gives nitrosamines. Now, these were the certain brief outlays about ozonolysis reactions. So, we have to focus on the first part of it. That is oxidation of alkene with the help of ozone. Now, ozonolysis reaction takes place with the help of ozone, which is a very reactive allotrope of oxygen. So reaction of ozone with alkene and some of the cases alkynes, this causes oxidative cleaving of the unsaturated compound. The carbon-carbon double bond or triple bond is replaced with carbon-oxygen bond, giving the required carbonyl compound, which is also shown in the figure adjacent in your diagram. Now, ozonolysis mechanism of alkenes that we have to focus on. So, alkenes can undergo ozonolysis to form alcohols, aldehydes, ketones, or carboxylic acid. The general procedure uses a solution of alkene in methanol. Ozone is bubbled through this solution in approximately at a temperature range of 780 Celsius. When the solution turns blue, the alkene is assumed that it has been completely consumed. The blue color, this comes out of unreacted ozone. That means now only ozone is left and all of the alkene has been consumed. Now, as ozone is added to the reaction mixture, the reagent must be added to convert the ozonide to the required carbonyl derivative. For this, there are two pathways, a reductive pathway and an oxidative pathway. Now, the reductive pathway uses reducing conditions, oxidative pathway uses oxidizing conditions. Let's see them. First, we will see the step 1 that is shown in box 2. The electrophile added to ozone to the carbon-carbon bond forms a molozide intermediate which is quite unstable. Due to this unstable nature, the molozide continues reacting, breaking apart to form a carbonyl molecule and a carbonyl oxide molecule as is shown below. So the carbonyl oxide molecule that is shown below, I have drawn it in the black box. This is known as a Kriege intermediate. So the dipolar cycloaddition of ozone to alkene results in the formation of primary ozonide or Kriege intermediate. This is known as a Kriege intermediate. In step 2, the carbonyl molecule and the carbonyl oxide, both these which are formed in step 1, they rearrange themselves, reforming to create a more stable ozonide intermediate. Now an ozonide is formed. The ozonide intermediate, this can be subjected to either an oxidative pathway or a reductive pathway. Now, oxidative pathway forms ketone and carboxylic acid, whereas the reductive pathway forms carbonyl compounds. So, this is how the ozonolysis or reaction or oxidation with ozone takes place.